Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over how to identify whether a reaction is a redox reaction or not, and that's going to involve how to assign oxidation numbers and figure out from there whether or not something is oxidized or reduced. And in addition to that, we'll talk about how to identify the reducing agent and the oxidation or oxidizing agent. So let's get into this. So the first thing we want to do is remind ourselves of how to identify oxidation and reduction. So the first thing is remember the mnemonic device, oil rig, or if you prefer, Leo Gur. So these are two mnemonic devices that you can use to help you remember oxidation and reduction. So oil is oxidation is loss of electrons, oil, and rig is uh, reduction is gain of electrons, rig. So oil rig is a mnemonic device to help you remember that. So oxidation is loss, OIL. Oxidation is loss of electrons, RIG. Reduction is gain of electrons. Or if you prefer Leo, Gur, Leo the lion goes Gur. Here it's loss of electrons is oxidation, LEO. Loss of electrons is oxidation. And then Gur is gain of electrons is reduction, GER. Gain of electrons is reduction. So those are two mnemonic devices that you can use to help you remember reduction and oxidation. So that is going to be what we're going to use. Now, the other thing you need to be able to do is assign oxidation states to each atom in the compound or element that you have. But there are rules for assigning oxidation states. And if you don't know those rules, then please go see my video where I go over the rules for assigning oxidation states. I'll go over some of those rules as I go through the problems, and I'll talk about those as we go on. Okay, so the first thing we need to do is assign the oxidation state. So we'll start with A. So here we're given a reaction. We need to identify it as a redox reaction or not. So we need to first always assign oxidation states. So let me use a different color. So we got to assign the oxidation states. So we'll work our way down. So for this compound, we have calcium and phosphate. One of the rules for oxidation states is that monoatomic ions have a charge, and their charge is the oxidation state. So the charge on calcium is a positive 2. So that is the oxidation state of carbon. So we'll just write a 2 plus. Oops, I'll write a plus 2. Okay, so a plus 2 for the oxidation state of carbon. Now for phosphate, that's an ion too, but we're going to assign oxidation states to each atom in the ion itself. So phosphorus and oxygen will have oxidation states. Okay, and so another rule is that the oxidation states of the atoms that make up your ion should add up to the charge, the overall charge on the ion. Same thing goes with neutral compounds. So the charge or the oxidation states of the atoms in a molecule should also add up to 0 because molecules don't have any charge, right? So that's another rule that needs to be followed. So here the overall charge on phosphate is a -3. So that means that the oxidation states of my phosphorus and my 4 oxygens should add up to a -3. So first we're going to assign oxidation states to oxygen. Oxygen takes precedence over phosphorus. Again, this is part of the rules and the priority given to certain elements over others. oxygen as part of a compound is going to have a -2 oxidation state. So I'll put a -2 over there for your oxygen. And then for phosphorus, we have to figure out what the oxidation state of phosphorus by a little math. So I'll write over here. Let me use a different marker. So I know that phosphorus, whatever the oxidation state of phosphorus is, plus the oxidation states of oxygen. We have 4 oxygens, so we're going to multiply that by 4. So we have 4 oxygens, whatever the oxidation state, we said that was going to be -2. These two added together have to equal a -3 because that's the overall charge on the phosphate. So if I plug in the oxidation state of oxygen, right, so that's going to be whatever the oxidation state of phosphorus is, plus 4 times the oxidation state of oxygen, which is -2. And that's going to be equal to a -3. So now all I do is solve for P. So this is going to be P plus -8 equals -3. We're going to add, oops. Sorry about that. So over here, so we're going to add that. Well, so this negative and a positive, that's just going to be a negative. All right, so then we're going to add 8 to both sides. And so that means P is going to be equal to plus 5. So that's the oxidation state on phosphorus. So oxidation state on phosphorus is going to be a plus 5. Okay, so now we get to silicon dioxide. We do the exact same thing. So we have a compound here. So oxygen takes precedence over silicon. So this is not an ionic compound. So again, oxygen is going to have a -2 oxidation state. So we're going to put -2. And then silicon is whatever's left over. So I'll do silicon. So I know that since there's no charge on SiO2, the sum of all of the oxidation states should add to 0, since the overall charge is 0 on this. It's a molecule, not an ionic compound. So I know that the oxidation state of silicon plus, now I have 2 oxygens, so whatever the oxidation state, I have to multiply by 2. And then oxygen is going to be a -2. And that's going to be equal to 0 because the overall charge on the SiO2 is 0. And so this is going to be Si plus 4 equals 0. Oops, that's going to be -4 because of negative. So then we're going to add 4 to both sides, and that means the oxidation state of silicon is a +4. So we can go ahead and put a +4 here. And then we get to carbon. Now for carbon, the rule is that elements are going to have an oxidation state of 0. So elements by themselves have 0 oxidation states. So this is going to be 0. Okay, now we get over here. We have phosphorus by itself. Again, elements that are by themselves is going to be oxidation state of 0. Here we get carbon and oxygen together. So again, we have a compound, carbon monoxide. It's at 0 overall charge. So we're going to start with oxygen because that takes precedence. And so the oxidation state of oxygen is going to be, again, -2. And since the oxidation state of carbon plus the oxidation state of the oxygen must add up to 0 because there's 0 charge on this molecule, then that means that carbon must have a +2 oxidation state there to cancel out the -2. Okay, finally we get to this one, calcium. Calcium again has a +2 charge, so that doesn't change. So the oxidation state is +2 for calcium. And then we got to do the same thing that we did before. So here we go. So here, SiO2, that's going to have an overall -2 because that balanced the one calcium. So this has a -2 charge. So I have one silicon. So the oxidation state of silicon plus the 3 oxygen. So that's going to be 3 times whatever the oxidation state of oxygen is. And so those two added together is going to be equal to a -2 charge. So I'm going to start with oxygen. Oxygen comes first. So I'm going to assign oxygen a -2. So that's going to be the oxidation state of silicon plus 3 times -2, which is the oxidation state of oxygen. And that should all equal -2 because -2 is the overall charge on that ion. So then I just do the math. Si plus 3 times -2, that's going to be a -6. So we'll say -6 equals -2. And then we're just going to add 6 to both sides. And we get silicon is equal to +4. So we're going to put a +4 for the silicon and -2 for the oxygen. Let me write that better so it looks clearer. So that's going to be a +4. Okay, so now that we have all of the oxidation states taken care of, now we can see what's been oxidized, what's been reduced. Now remember, oil rig, oxidation is loss of electrons. So if you lose electrons, that means you're going to become more positive. If you gain electrons, you're going to be more negative. So we got to look at what elements became more positive or more negative. Okay, so oil rig, oxidation is loss. So we look at calcium. Calcium is a +2. Calcium is a +2. No change. So nothing happens there. Phosphorus goes from a +5 to 0. So it became less positive, or another way to put it, it became more negative. Less positive or more negative. In order to do that, it had to gain negative electrons. So to go from +5 to 0, it had to gain negative electrons. So gaining electrons is what? Rig. Reduction is gain electrons, or GER. Gain of electrons is reduction. So that means that in this case, P was reduced. Okay? So right here, so we'll put a line under P. So P was reduced. We'll put an R there for reduced. Okay. Now, so if we keep going, we'll look at oxygen. Oxygen has a -2 here. Oxygen has a -2 here. And oxygen has a -2, -2. So the oxidation state of oxygen didn't change. So it's nothing's going on with oxygen. Now, if we go to silicon, you'll notice silicon has a +4 here, and silicon has a +4 there. So there's no change in the oxidation state, so nothing going on there. Okay. So if we go to carbon, carbon goes from 0 to a +2 here. So in order for carbon to go from a 0 to a +2, it had to lose electrons. So losing electrons means you're losing negative charge, and so you're becoming more positive. And so that's going to be the oil part of the mnemonic device here. Okay, so now that we have figured out what has been oxidized, what has been reduced, we are now in a position to figure out what the oxidizing agent is and what the reducing agent is. And so before I go into that, I just want to point out that it should go without saying that if indeed you have an element that has been oxidized and then an element that has been reduced, then the equation is indeed a redox reaction. So the hallmark of a redox reaction is that something is oxidized and something else is reduced because there is a transfer of electrons, right? So in order to have oxidation and reduction occur, they occur simultaneously together because one thing is donating or transferring the electrons from one thing to the other. So the thing that is losing the electrons to something is the thing that is undergoing oxidation. The thing that is then receiving those electrons is going to be the thing that is undergoing reduction. And so oxidation and reduction happen simultaneously together. Okay, so now let's identify what the oxidation reagent is. So before I do that, so identify. So here, the carbon has been, it goes from 0 to +2. So it lost electrons, so it undergoes oxidation because oxidation is loss of electrons. Oil rig. And so now we can identify what the oxidizing agent and the reducing agent is by understanding that whatever gets reduced is the oxidizing agent, right? Because the oxidizing agent is the thing that's giving the electrons to the other thing, right? And therefore causing the other thing to be oxidized. But in the process, it is losing the electrons and therefore undergoing reduction, right? The oxidizing agent is the thing that's taking the electrons away. So therefore, it's causing the other substance to lose the electrons and therefore become reduced become oxidized, and therefore it becomes the reducing agent. So let me say that one more time. So the oxidizing agent, right? So oil oxidation is loss of electrons. So the thing that is being oxidized, the thing that is losing electrons, is giving those electrons to something else. In the process of giving those electrons to something else, it's causing that something else to pick up the electrons and therefore get reduced, right? So then therefore it becomes the reducing agent by giving its electrons to something else. However, the reducing, or I should say the oxidizing agent, is going to be causing the other thing to lose electrons by taking them away, right? So if I am taking the electrons away, then I'm causing that other thing to lose electrons, and therefore it's going to uh, undergo oxidation, and then in the process, because I'm picking up the electrons, I'm undergoing reduction. So whatever substance is undergoing the reduction, or whatever element, I should say, is undergoing reduction, that substance that contains that element is the reducing agent. So the reducing agent, how do I put this? to identify the reducing agent, you find the thing that's being oxidized. So here, for example, so we pointed out that the phosphorus here is being reduced, which means that it is gaining electrons. Well, it had to gain those electrons from somewhere else. It's gaining them from the carbon, so it's taking them from the carbon. What happens to the carbon? It gets oxidized. So it's causing the oxidation of the carbon. Therefore, it's the oxidizing agent. So, but this is, you got to be careful there. The phosphorus is not the oxidizing agent, it is the whole compound. So this whole compound is the oxidizing agent. So we would say this here, right? So the calcium phosphate is the oxidizing agent because that's the substance we're talking about. Okay. And now for the opposite end, so this is the oxidizing agent. I'll just say OA for oxidizing agent. And then for the reducing agent, well, you look for what's got oxidized. The thing that got oxidized is going to indicate what is the reducing agent. So in this case, it's carbon. So carbon isn't part of a larger molecule or substance. So in this case, the element that got oxidized is in itself the reducing agent. So it's the carbon in this case, because that's the only thing here. It's all by itself. So the carbon element gets oxidized, and it is the reducing agent. So here, I'll mark this as Ra, reducing agent. So the thing that gets oxidized is the reducing agent. The thing that gets reduced is the oxidizing agent, if I was put it simply. Although it's not quite accurate to put it that way. Because the element here is reduced, but the oxidizing agent is the whole compound, not just the phosphorus. So don't make that mistake. So the oxidizing agent isn't the phosphorus, it's the whole compound that contains the phosphorus. Okay, so I hope that's clear. Okay, so let's go ahead and do the next one. So I wanted to take my time with this one to make sure that everyone understands how to identify oxidizing substances, oxidation agents, and stuff like that. So I'll go faster with the other ones. So for B, I have phosphorus by itself. So I got to identify the oxidation states first. So I'll identify phosphorus. That's an element by itself, so it has a 0 oxidation state. Oxygen is an element by itself, so it has an oxidation state of 0. So oxidation state of 0, oxidation state of 0. And then here we have water. So what we're going to do here is give oxygen its oxidation state first. So oxygen takes precedence over hydrogen. So we'll give that its oxidation state. The rule is that anytime oxygen is in a compound, it has an oxidation state of -2, unless it's a peroxide. If it's a peroxide, it would be -1. So in this case, it'd be -2. And then hydrogen gets what's left over. Hydrogen normally has a plus charge, an oxidation state of a +1. And so if we identify here to balance the charge or balance the oxidation state here, you have a 0 charge on the molecule. So the total of all the oxidation states must add up to 0. So that means that since I have two hydrogens, the oxidation state of hydrogen should be a +1. So it's a +1 there. And then for this compound here, it's got 0 charge. So the overall oxidation states of all the substances should be 0. So we'll give oxygen first its oxidation state of -2. And then we'll give hydrogen, its oxidation state of +1, because the rule is after oxygen, hydrogen gets its oxidation state, and so it normally has an oxidation state of +1 in a compound. And then for phosphorus, phosphorus will get whatever's left over, and so we got to do that calculation. So here we have 3 hydrogens. So the oxidation state of 3 hydrogens, let me use a different color. So we got 3 hydrogens. So the 3 times the oxidation state of hydrogen plus the 1 phosphorus, the oxidation state of phosphorus, plus the 4 times the oxidation state of oxygen. And that's going to be equal to 0. And so we can figure out what the oxidation state of phosphorus is by plugging in the oxidation states of hydrogen and oxygen. So we have 3 times +1 plus the oxidation state of phosphorus plus 4 times -2 equals 0. And now we can solve for the oxidation state of phosphorus. And so then we got, this is going to be a 3 plus oxidation state of phosphorus plus, and this is -2 times 4 is going to be a -1, so that's going to be -8 equals 0. Add these together, we get P minus 5 equals 0. And then we solve for P, so P is going to be plus 5. So the oxidation state of phosphorus is a +5 here. So we'll put +5. I'll draw an arrow. So +5 for phosphorus, -2 for oxygen, and a +1 for the hydrogen. And so now we can see what got oxidized, what got reduced. Okay, so reduction, what got reduced. So we got 0 for phosphorus, and then here we got +5. So phosphorus went from 0 to +5. It became more positive, less negative. So it lost electrons. So oil, oxidation is lost. So that underwent oxidation. So we use red for oxidation. So oxidation, phosphorus. So oxygen here went from 0 to a -2. So it picked up electrons. It became more negative, right? So that means that the oxygen here got reduced. Okay, so we have oxygen reduced. Here, hydrogen stayed the same, +1, +1. This oxygen here stayed the same, right? So this oxygen here went from, this didn't change. So then nothing happened here, but here it did. So now we can identify what the reducing agent and oxidation agent is. So remember, the reducing agent gets oxidized. Phosphorus got oxidized. So since this is just, this is going to be the reducing agent. Okay, and then the oxidizing agent gets reduced. This got reduced, so the oxygen here, the O2, is your your oxidizing agent, OA. Okay, I hope this is helpful. I'll continue this in my next video. I'll do the last 4 problems. So if you like this video, continue watching into part 2. If you like my videos, please like, share, subscribe. Hit that like button, subscribe to my channel, hit that notification bell when you do, and when you do, click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any questions or problems you want me to help you with, or if you have a topic you would like me to cover, let me know. I would love to do that for you. Thanks for joining me, and have a great day.